Alright, so in the last video we recovered our RNA from PAGE through ethanol precipitation. Here we have 20 microliters of our elution. And now we're going to spec in the biodrop to determine how many picomoles of RNA we recovered in this round. So first we're going to set the biodrop to RNA because we have an RNA sample. We're going to make sure that the integration is long. Integration time is 5,000 milliseconds. The path length is biodrop U light 0.5. We're going to set the wavelength to 380 nanometers, and we're going to make sure the concentration is set to nanograms over microliters. So here's a nanodrop. First we're going to take a reference sample with water. First we have to clean the nanodrop. So here I'm wetting a chem wipe with water. I'm going to pass the wet chem wipe over the sensor and dry it off the other side of the chem wipe. Okay, place that back. I'm then going to add 1 microliter of water to the biodrop. And this is to run a blank in the biodrop. So here I'm adding just 1 microliter of water. Okay. Now I'm going to hit reference here. Okay, good. So this should be a flat line because it's a blank, so there's nothing in the water. We're then going to wet and dry off the sensor again. And now we can add our RNA to determine how many picomoles we recovered. So here I'm adding 1 microliter of our RNA that we recovered from PAGE. Okay, so this is a spec reading of our RNA. You see we collected 458 nanograms per microliter. So now we can use this to see how many picomoles were recovered through some simple calculations. So congratulations, this is the end of round 1 of Selex against lysozyme through the filter-based method.